Hello, and welcome to ISI Insiders, the flagship podcast of spooky action at a distance. We're going to unpack that. Here on this podcast, we get a chance to go inside of ISI, the famed and now 50-year-old Information Sciences Institute, to meet some of the ISI insiders in order to better understand their what, their how, and their why. That is, what they're doing, how they came to be doing it, and frankly, why. With their ability to go anywhere else, why are they here working on this right now? And why might we care? Hi, I'm Adam Russell. I'm director of the AI division at University of Southern California's Information Sciences Institute, and I'm your podcast host. I'm serving as your virtual guide as we talk to some of these ISI insiders, all to test my hypothesis that by better understanding this, by better humanizing the people who are doing the actual work that we hear about in the media or that appear as names on publications or conference talks, we might get a better sense of where things may be headed, or at least where these folks think we might be headed, as well as where they think we should go and how we might get there. My guest today is Dr. Jonathan Habif. He's a research assistant professor of electrical and computer engineering in the Viterbi School of Engineering and a principal scientist here at the Information Sciences Institute, and therefore a colleague of mine. I'm very excited to talk to him today, especially since he is also the head of the Laboratory for Quantum Limited Information. Words that I know how to pronounce, but I'm not sure I really understand what they mean. So I'm looking to John to help explain that. John, welcome to ISI Insiders.
Thank you so much. I'm a huge fan of the show, so very glad to be here.
Well, we should probably stop there. Got what I needed, which is affirmation. No, kidding. All right. So if you listen to the show, then you know we show no mercy to our guests. We throw curveballs after curveball after curveball. So let me start with the first one. I suppose I should start with some sort of quantum reference of we can be here and there. We can be here and there at the same time in accordance with quantum. I have no idea if that's true. But go back in time. Let us come with you, and I want to hear you talk to your sort of 14-year-old self about what you do and kind of how you got here. And then would this surprise your 14-year-old self? Like, where are you in the world at 14?
Yeah, so I think I'd be really proud to go back and tell my 14-year-old self what I'm up to now. Because when I was 14, I really wanted to be an inventor. I loved looking at things and coming up with new solutions to problems that I sort of saw in the world, whether it was, something going on in the kitchen or something going on in the world or something I saw in the news. And so I think that I would tell my 14-year-old self, you did it. You're an inventor. Now, kind of a specific type of inventor in that I try to understand the laws of quantum mechanics and figure out how we can use those laws to do new things, to invent new capabilities. But ultimately, I like to consider myself an inventor.
Would your 14-year-old self understand that? Or would it be like, what, dude, we want to make jetpacks. What are you doing?
Yeah, I wouldn't understand any of it,
Gotcha.
I think.
Yeah. That's fair. Okay, so I just got an email from your 14-year-old self who said, whoa, you still haven't explained to me, what does it mean to be an inventor at the quantum level? Like, explain to your 14-year-old self, like, what are you talking about, this quantum information stuff?
Yeah, so the dean of the Viterbi School of Engineering is Yanis Skortsos. And every time he starts a talk, he always says that he believes engineering is understanding how nature works and applying it to solve problems. And so in my head, what I hear is understanding how quantum mechanics works, the real fundamentals of quantum mechanics and how nature behaves quantum mechanically, and then using that understanding to solve problems. And so the problems that we're solving is asking questions like, well, what if we are looking out into space and we see one quantum particle come into our detector or receiver or whatever? Mm-hmm. How do we understand what a measurement on one quantum particle can tell us about where it came from? How would you be able to tell whether or not that particle came from, that particle of light, that photon came from a star or a quasar or some other thing in deep space? Or did it come from a laser? And if it came from a laser, that means it came from a civilization that itself understands quantum mechanics and knows how to build things with it. So that may be a little bit of an esoteric answer or example, but it's one of my favorites.
when science increasingly is a team sport, at least in AI and other areas, is quantum also sort of a team sport in that sense? Do you spend a lot of time working by yourself, or do you really spend a lot of time with teams?
Absolutely team sport.
Hmm.
Yeah. And, one of the real privileges of my career has I've been able to spend time with, learn from, and collaborate with great theoretical physicists. I'm an experimental physicist, so, I like to get my hands dirty in the lab and break things and then fix them and get things to work and oscilloscopes and the whole thing. But it is such a treat to have a conversation with and learn from a theoretical physicist who thinks in a very abstract and mathematical way. And I think they really enjoy too seeing their ideas actually pushed down onto light and experimentally implemented in the lab. So I think every project that we have by design is a collaboration with a theorist or more theorists.
Yeah, from the outside, I've always had this sense that they are sort of warring factions or tribes, and you don't want to let like separate species. You don't want to let them into the same room, or it'll turn into like a big theoretical or empirical knife fight. But you're saying that not necessarily true. Do you? What's the secret? I mean, there are obviously people who can't get along, who don't, teams that don't gel well. In your experience, are there pointers you have for like how to build a good team?
The pointer that I have, or the what I always use is try to read their papers.
Hmm.
So when theorists write papers, for me, man, they're hard to read. But if I sit down and try to work through them and then ask questions, people love to talk about their own work. And so if I can go and spend a lot of time reading their paper and ask questions and then come up with ideas about how we could implement in the lab, that really generates a lot of synergy, a lot of excitement, and just a really collegial atmosphere.
Interesting.
Yeah, I want the students to do that too, to learn that early because I didn't learn that until later.
Yeah. So the way I usually ask this question is about what do you think is your sort of superpower, your secret power when it comes to building teams? Synopsize that for me, though. It sounds like to me that is kind of your superpower. How would you describe that? Is it just curiosity, or is it more than that? What is it?
So it may sound silly, but I think one of my superpowers is that I'm not actually all that smart.
Hmm.
It takes me a long time to sit with a concept and really absorb it and understand it. But once I do, then I feel like I understand it in my core and I can really expand on it and use it to come up, use it as a solution to a real problem in the real world. And so I think that the requirement that I sit and read and think for a long time ends up being, I won't call it a superpower, but maybe a semi-power.
No, I like with the League of Justice or whatever. I think the point that what on the face of it individually would appear to be a limitation, perhaps, is actually a real power. One, because it gets you to do it that way, right? You have a metacognitive capability to address that. But two, because that actually opens doors for other people in the team. You're able to engage with them at a level that people who think they get it right away, don't.
Yeah.
I think, yeah, that's actually really insightful. So you mentioned hoping that your students would do the same thing, or at least would take the same sort of approach. What other, for quantum or other areas, information sciences, what other advice would you offer younger people, especially in the face of like just the rapidity of technological development, advancement? I mean, there are disciplines that are probably going to disappear, new ones that are rising. Like what? Yeah, how what would you offer them as guidance going forward?
The things that I really try to instill in students is one, get curious, and two, get confident, and three, get active. So getting curious is asking a ton of questions, really sitting with ideas and thinking about them and asking yourself questions and then looking at the answers. Getting confident is the ability to march straight up to me and ask me a question. Tell me that you don't understand something. And then get active is get in that lab, turn knobs, plug things together. If something breaks, don't worry about it. We'll fix it or we'll throw it away and buy a new one. That's how science is done. And so just getting a little bit maybe aggressive is the wrong word, but confident and active, I think will get you a long way.
Interesting. So almost, yeah, engage, right? Engage with people,
Yeah.
engage with this topic matter. Because a lot of people hear confidence and they think, well, confidence means I don't acknowledge when I'm wrong. Confidence means, I've got to be right all the time. Your point is, on the contrary, if you're really confident, you are actively seeking to figure out where you're wrong. You're actively seeking to, yeah, learn along those lines. With your perspective on things, what do you are you? It sounds like you're generally more optimistic about the future, but what do you worry about most with sort of technological acceleration and convergence? Are there things you are concerned about?
Yeah. So my biggest concern, and this is a concern for the world as a whole, is our general separation, increasingly large separation from the natural world.
Hmm.
And so one of the prime examples is when my family wants to know what the temperature is out,
Hmm.
they ask Alexa. And I'm trying to get them to just open the door and stand outside and feel what the temperature is out.
An empirical scientist. I like it. Yeah.
Well, there's also just this incredibly growing gap
Hmm.
between our senses and nature. And this is one of the reasons I started this lab, is that when we think of information now, the first word that comes to mind is we think of bits. But actually, there is a very deep and beautiful connection between nature and information. And that connection is a quantity called entropy. And so entropy is really a measure of disorder, a disorder in anything. It was the famous information theorist Claude Shannon that said that understood this deep connection and abstracted away this quantity bits. Your ability to extract information from the physical world is limited by that entropy. So a great example actually is, I have two young daughters, and their room can go from very clean to very messy. And if you ask them to go find their soccer jersey, when their room is very messy, it's got extremely high entropy, right? And
Hmm.
so the probability of finding that soccer jersey, it could be anywhere, and it would take them a long time to find that jersey. So the entropy is very high and the information is very low.
Hmm.
On the other hand, if the room's clean, you know that soccer jersey's in the top left-hand drawer, right?
Right.
And they can
Right.
get that information immediately. So that's sort of an example about the deep connection between entropy and information
Hmm.
that is really ubiquitous in the physical world.
Yeah, we at our house we do actually call it fighting entropy,
Yeah,
and because it actually requires energy, right? I mean, to bring
that's
order and
exactly right.
structure to it. Yeah, the house, but like the universe itself, sort of wants to lend itself to total disorder. Yeah, that's really interesting. We started this off mic talking about sort of AI. You were very humble about what you know about AI, but I mean, key to the notion of intelligence, obviously, is information. And you touched on information, the fact that we've seemed to have abstracted away information from sort of the natural world and biological systems, et cetera. How do you think about intelligence in that context?
That's a really tough question. This is probably a better question for an AI person, but
They're a dime a dozen, man. I don't get quantum
right.
physicists very often. So, yeah, no, there's no right answer, obviously, and it's an unfair question. That's what we do here.
Yeah, right. So, when I go out into the world, so I'm an avid fly fisherman, and this
Hmm.
is like the best way that I can connect with nature. And so I think about intelligence in terms of learning and I being able to identify patterns in nature. And so, for example, when I go to the river, the first thing I do is I sit there and just observe and I look for patterns. Which way is the wind blowing? Is it always blowing in that direction? Where's the sun? Where are the bugs coming off the water? Are there fish feeding? And so I've become a better fly fisherman over the last 20 years
Hmm.
because I've become better at recognizing those patterns. First time I walked into a river, there was so much entropy. I couldn't tell what was going on. Everything just looked like chaos, and I'd throw my line into a tree, right? But now I'm slightly more intelligent. I'm a little bit better at picking information out of the entropy. And
Yeah.
so I think that there's a connection there between the natural world and intelligence and learning.
Yeah, you've touched on something I've been thinking a little about, not very clearly, I admit, but this notion of we are so fixated around asking the question of what intelligence is, and yet what you just described is more a question of what is intelligence for? And I think it's
Mhm.
a different turn on the question, and maybe a better question. I don't know that entirely. Your fly fishing interest, do you see any way that it contributes to your professional activities in quantum? Is there some, do you learn things in sort of your hobby that apply?
Oh, it's the absolute immersion in nature, right?
Okay.
Because you are not going to be a successful fly fisherman if you aren't sitting there observing, absorbing, and sensing nature with your eyes, with your ears, even with your touch. How cold is the water? How cold is the air? So I'm not sure if science has made me a better fly fisherman or fly fishing has made
Yeah.
me a better scientist. But, sometimes in the laboratory, when something isn't working, a lot of times students want to throw switches and unplug things and plug them back together. And let's just take a breath and think and observe and see what's happening on the oscilloscope without touching anything. But Mother Nature is trying to tell us something. Shut up and listen. And so I think that's probably a good principle in a lot of different areas of life.
John, the hardest question of all on this podcast for anybody traditionally has been, do you have a good AI joke? I'm going to give you a chance. You can offer a good AI joke if you have one and really just flex on the AI people. Or do you have a good quantum joke?
So I have a quantum joke. I won't give it the qualifier of good.
There he is. I like it. I like the humility, but let's go.
So two atoms are watching a photon come down the street, and one atom said to the other, "Hey, don't get too excited." That's it.
But
Yeah, thank you.
I think I understand. But the point of humor is I can't explain the joke. Uh, Also, as someone named Adam, I appreciate
Exactly.
the
Yeah.
eponym. Yeah, that's funny. Do you this you said this is your first podcast. You would never know. You are a natural. So let me ask you then, if you had a podcast, what would it be about?
Yeah. So it would be about the search for non-human intelligence
Hmm.
and probably building tools to search for extraterrestrial intelligence. So I am a believer that I think we are not alone in this universe, and that's something that I would love to spend more time thinking about.
Yeah, that's really interesting. Um, I guess we're starting to come on time. I really do appreciate you being on here. It is my absolute privilege and pleasure as director of AI division at ISI, but also just the podcast host to get a chance to talk to folks like you. And you mentioned earlier that if I can summarize, the advice is to be curious, to be confident, and to be active. All of which basically comes down to like get engaged. Mate, this has been a very engaging podcast. So thank you.
It's my pleasure, and I was really grateful to be invited on. Thanks, Adam.
Well, if you enjoy these short podcasts, please do what only you can do, or at least we only want you to do, because that would be most informative and would reduce our entropy. Rate us, score us, evaluate us, grade us, subscribe, spread the word, send us feedback, offer up brave questions, and of course, please keep listening and learning. And join us, please, for another episode of ISI Insiders, where we'll keep exploring, keep learning, keep humanizing tech to help navigate our way through this weird, weird world, trying to do what humans can do best when they face these kinds of challenges, working together as if all our lives depend on each other, because they do. So for now and for the future, fight on.